But thank you obviously so much for joining us today. We're going to be talking about installing some snow-free driveways using our snow melting systems. My name is Lynn. I'm a customer service rep here at WarmlyYours, and my co-host is
Scott. Thanks for joining us.
Awesome. So today, if there's any questions, please don't hesitate to ask. If we don't see them right away, we'll definitely get to them by the end of the presentation. But yeah, just type them out and we'll be definitely happy to answer whatever you'd like to chat about. So today we are going over kind of just some general information of our snow melting systems. We're also going to go over some example projects. So we're going to show you a full coverage heating system from start to finish, how that project was done, all the installation, everything like that. We'll go over some general installation information and some information on the controls, as well as an example project with a little less coverage, doing what we call our tire track coverage and kind of showing the differences there. So our snow melting systems are all electric. That's what we do here. That's what we are best at is electric snow melting systems. And they're designed to be embedded in some kind of non-combustible material like concrete, asphalt, mortar, anything like that. So Scott, can you kind of tell us the difference between the snow melting mats or cables or what the, pros and cons can be?
Well, first of all, I think it might be a good idea to talk about the differences between electric and hot water.
Good idea.
I just thought about that overnight and I slept very little, making sure that I mentioned that today. But one thing that you'll notice missing in our cross sections is the requirement for insulation under the product. Insulation is required for hot water. So you put the insulation down on the dirt, then you put the hot water tubes on top of that, and then you do whatever you do to install the driveway or the sidewalk or whatever. Our product does not need that because the temperature at the beginning of the cable or the temperature at the beginning of the mat is the same temperature as it is at the very end. Unlike hot water, where the hot water comes in, it's much hotter than where the hot water goes out. So we're very, very efficient. We don't lose heat. So it's the same temperature at the beginning as it is the end. So you don't need to have that insulation underneath to keep it from, to help boost that power of the hot water. Snow melt cable is predominantly used in stairs to get from one stair up the riser to the other stair. Makes it much easier to do that. And it's also used in areas that are not rectangular. So circular areas like this will have a cable running like this to fill that space. It's very difficult to do that with a rectangular product with like a snow melt mat. But if you're doing a rectangular driveway, if you're doing tire tracks, snow melt mats are, or rolls, however, whatever you want to call them, are the fastest way to do installs. Anything that's rectangular, because you can cut the mesh and turn it and do that type of thing in a rectangular space, and it's much faster to install. Literally, you have to take the snow melt cable and attach it to rebar or whatever is underneath it to hold it in place manually with cable ties. And you don't need to do that as much with the snow melt mat. You can actually do it a further distance apart so you don't use as many cable ties too. So there's a lot of different uses. Once we see, if you send us a drawing, we'll give you a pretty good idea of what product best fits that space. That's what we're good at.
Absolutely. So looking at snow melting specifically for asphalt, I know, Scott, you were actually involved in, many different projects where we were doing snow melting with asphalt. So can you kind of give us an overview of what that looks like for the installation?
Yeah, this one right here, we did. This is a full coverage mat in asphalt. On the right side, you can see the binder coat that was put in a week or two in advance. That's why it's a little bit lighter color. Some people say, is that dirt or is that gravel? No, that's the binder coat. That's the bottom coat. And that was put down with a paving machine. This layer on the left, which you can see the guys working with rakes, and you can see just a little bit of that cable there in the middle between that two guys' feet, or between that guy's 2 feet there. That's put on by hand. But once you say put on by hand, it scares all of the asphalt people. It's like, oh, no, we don't want to do it by hand. We just want to do one layer of 3-inch asphalt. So we're going to put it down on the rocks. No. Then we're going to cover it with 3 inches of asphalt. No, that's not the way to do it. You need to have the binder coat, which is 2 inches. Then you lay the product on top of it, and then you put another coat of 1.5 to 2 inch thickness over it. National Electric Code says it has to be 1.5 inches thick at least. So we want to be right there at the 1.5 to 2 inches, because the closer you get to the top surface, the better it's going to melt. So that's why and one of the multiple reasons why we don't want a cable 3 feet, 3 inches under asphalt. It just
Or
doesn't,
3 feet.
or 3 feet's even worse. So yeah, that's what you want. So this is an area that we did the entire area, most of the area coverage. So what I want to draw your attention to on the right side is an overhead dump. And that's what you use to get that asphalt over the top of the heating mats. So when you say we're going to do this by hand, every asphalt person that hasn't done this before thinks, oh no, I've got to get wheelbarrows. I've got to have guys pushing wheelbarrows up the hill. No, you don't have to do that. But you can't drive anything over the cable until that top layer is rolled. So we're going to see how to do that. And we've got a video that you can send an asphalt person if you're interested in doing this job, that'll take the mystery completely out of it for that asphalt person and give them a great overview on how to do this install.
Absolutely. So we talked a little bit now a few times about the different coverage options available with snow melting systems. So this first project we're going to go over, the one the picture just showed, is a full coverage installation, meaning that that snow melting mat fills the entire surface area of the driveway. Now, if you're looking at more of a budget option, or if you have limited power, or maybe you just have a really long space and you don't need to do the entire thing full coverage, you can definitely do tire track coverage as well. And can you kind of tell us, Scott, what that is?
Yeah, the full coverage is, first of all, if you notice that these rolls are kind of initially placed there in the top picture, and they're going to be 3 inches apart from one another, because the wire is always spaced 3 inches apart from one another, because the heat only travels laterally from a heating cable about 1.5 inches either direction. So if you have one cable here and one cable here, and they're 3 inches apart, this cable will throw heat 1.5 inches, and this cable will throw heat 1.5 inches, and that's how you get a nice coverage, smooth coverage for your entire area. And you never ever can overlap the cable. So by spacing them 3 inches apart, you never have to worry about those cables overlapping, because if those cables overlap, you're going to be in trouble because they'll burn through. And the thing is, you can never ever shorten the heating cable. So you can't go, oh, I've got too much, I'm just going to cut it off here and then be done. You can't do that. You need to make sure that you get the right amount in there. So we're going to give you a plan, and we're going to show you the plan here very soon. But you've got full coverage, and you've got tire tracks, and the tire tracks should be centered. If your wheels are 5 feet apart, the center of your mat should be 5 feet apart. So that's going to be your tire track coverage to get up and down your driveway. And it's the most economical way. It costs less up front. But what you really need to think about before you even get to this point is go to your breaker box and see if you have any available breaker spaces in your breaker box. Because if you don't have any spaces, you're not going to be able to get this electric heating, or you're going to have to get another service or another box put in. So the first thing you want to do is look in your breaker box and see what you have.
Absolutely. Definitely a good point to consider at the beginning. So this is a really great cross section showing a snow melting system in asphalt, and it's really exactly what you were talking about earlier, Scott. It's a good way to see it. So there's that compacted gravel base, the base coat of asphalt, and then the snow melting mat with the finished asphalt over the top.
Yeah, I've seen a friend of mine had an RV that was parked on a single layer of 3 inch asphalt, and after 1 year, it was just bowed like that, because that's what happens when you do a single layer. But this is the way you want to go, and the heavier the items that are going to be driving over, the thicker you want that compacted gravel. So if you're going to be driving, big trucks, you're going to want, 4 to 12 inches of that, because that's going to give you your strength underneath. You need that base coat. Then what you're going to do is you're going to put your mats over the top. And we don't even suggest using cables when it comes to asphalt, because the asphalt people are going to try to do these two pours all in one trip. So they're not going to wait. Okay, we put the binder coat now. Yeah, give me a couple hours to lay these cables out on this. Oh, no, no, no. We're not going to be sitting here a couple of hours waiting for you to lay these cables out. You want to have these this mesh cut and trimmed and already ready just to drop on so they can put the asphalt on top. And we're going to show you that a little bit later. But yeah, you need the two separate layers, and that's so important. You're going to see why.
Yep, absolutely. So like we said, we're looking at this project example. So this total area was 488 square feet, and we heated 469 square feet of that. So very close to 100% coverage. That tends to be about average. That's something I think a lot of people don't always think about. You can also do kind of a hybrid. You don't need to do all or nothing. You can do a smaller area of the driveway if you needed to.
What I'd
Looking,
like you to do, Lynn, before we go any further is could you just go back one slide? Is it possible to go back one slide?
oh, absolutely.
And here I want you to just notice something. We're going to be talking about it later, but you see there's a pipe between these two runs of heating cable rolls. That's where your sensor needs to go when you have an asphalt job. That's your over temperature sensor. That makes sure that that if the temperature gets to a certain point in your asphalt slab, that the control will turn it off because it's warm enough already. So I just want everybody to notice that's when we refer to an over temperature sensor with asphalt and why it's required, that's where it gets put, and it gets put in a capped conduit. So no asphalt gets in there and damages it, but that's what that is. And we're going to talk about it later. So I'm sorry. I just wanted to talk about it now since we had a picture of it.
No, absolutely. Good to go over. So looking at the power requirements, we'll actually provide you with all this information when you get a SmartPlan from us. We'll tell you exactly which breaker, how many breakers you'll need, what size. We'll tell you the total amperage of the project, as well as kind of a rough estimate of operating cost.
One thing I'd like to bring up about this is the breakers. When I go out and work on these systems, one of the major things that I see happening in these systems is people are using GFCI breakers, or they're not using any protected breakers at all. That's a big deal. The National Electric Code requires GFEP breakers, which is ground fault protection for equipment, which is a 30 milliamp trip, not 15 milliamp like a GFCI is for outdoors. So it's very, very important that to comply with your code that you get GFEP breakers. And that's one thing, whenever I go out and work on these systems, a lot of times I find that it's just a regular breaker. And then the other breakers are GFCI. It must be GFEP, ground fault equipment protection.
Yes, good rule of thumb, good note to have. So this is the kind of SmartPlan we'll send back to you. So what they probably sent in was a drawing of the area, and we'll actually rescale it. We'll draw it in our CAD program, and we'll send back a really nice, clean look or looking drawing like this, so that you can see exactly, how you'll be laying out the mats before ever beginning the actual installation plan. Scott, can you kind of tell us what we're looking at here? There's a lot of symbols going on.
Yeah, you see that big red glob there between rolls 2 and 3? That big red glob is that sensor that I was talking about. That's where it was installed. So you have a sensor, an over temperature sensor there, where it says in the lower left-hand corner OT sensor if required. Well, it is required for asphalt because it saves you money in the summer by keeping the system from turning on. And it also saves you operational money. If your slab is 80 degrees, you don't need to have your controller on anymore because your snow is going to melt if your slab's 80 degrees. So that's what that over temperature sensor does. You can see the drain there in the center that we worked our way around. And then all of the different rolls that are laid out in that area, they're numbered from 1, 2, 3, 4, 5, 6, 7, 8. Some of them are cuts and turns. Some of them are just straight. Some of them are 2 feet wide. Some of them are 3 feet wide. So it shows you all that information on the plan. And in the lower right-hand corner, it tells you what the total amperage is for that. And it's going to tell you down there. And in the middle, it tells you how many breakers are needed. So you can get all that information to your electrician because your electrician is going to have to be there in advance of the asphalt people because they've got to get the conduit installed. They've got to get the junction boxes installed. And one of the big mistakes I see when I'm out doing an installation is the electrician isn't there on install day. Well, the electrician has to be there to test the system while they're pouring the asphalt over, because if they damage it when they install it, the electrician has to say, oh, stop right there. Whatever you just did with your shovel just caused me to get bad readings. And they go, okay, we can fix that. So I've had to go out numerous times to go out and fix that spot before they can put asphalt over the rest of it. So if they do damage that spot, what they do is just make like a 2 or 3 foot spot that they don't put any asphalt. Then they continue working on the rest of the driveway. Then I'll come, or some other electrician will come and make that repair. Then they'll put asphalt over that, and then they're not holding up the whole crew, right? They found the spot. That's why the electrician has to be there testing it to know, hey, whatever you just did, stop, keep moving, and cordon this area off.
Yes, good, good information to know ahead of time. So looking at the actual beginning of the installation process. So once you have your mats and you're ready to go, you do want to make sure that you're testing your system since you are going to be covering it in something permanent. You want to make sure you're installing a working system. So Scott, as our resident tech genius, can you kind of tell us what we're looking at in terms of equipment needed and how to test a snow melting system?
Yeah, the control there, or the tester there is a mega ohm meter. Every electrician should have one of these. If you don't, you can get them online anywhere. But the product, when it's sent out, is tested with one of these every single time. So we know that every product that leaves here tests good. If it doesn't test good, we don't ship it. So we test it first, put it in a box, and send it. So we know it's good. But what has to happen is at the installation area, the people out there have to test it they test it when they get it to make sure it's good, because that establishes that the product we sent is good, because you want a good product to go in a driveway. You don't want a defective product to go in the driveway. So in theory, it should get tested twice before it even gets put down. Once when it leaves here, once when it's received, and then continuously as you go. And that's why you need one of these. So your electrician should have a mega ohm meter. I mean, I'm old enough where the first mega ohm meter I used was a crank unit with this dial going back and forth, and you cranked it and you cranked it and you cranked it. And this electronic one does it much, much easier. It's much more accurate. But you're going to need to have one of these, and your electrician is going to need to use it before it's installed and while it's installed. So very, very important to get this. You are going to need a mega ohm meter. And this is a very good one. This Hioki is really, I think it's only like 200 and some dollars. And that was, a good for an electrician to have.
Definitely. So this is very similar to that cross-section drawing that we talked about earlier, just kind of from a different view. So again, we're really trying to show exactly how the layers need to look and what layers need to go where. Scott, is there anything you'd like to point out on this drawing?
No, we talked about the thickness. We talked about the gravel. We do have to have, when someone says, I'm interested in doing one of these installs, we're going to send you this diagram. And this is what you're going to hand to the asphalt installer and go, this is what we need. The asphalt installer is going to tell you how many inches of crushed aggregate you need, depending on what your setup is there. They know the answer to that. But we do know that you're going to need this setup, and it's got to be in this order. But before you leave, before you leave that diagram, notice there is no insulation under the
Yes.
asphalt there. No insulation under the asphalt or between the asphalt or anything.
Yes, very good to point out. All right, so looking at the actual beginning of the asphalt. So obviously, like you said, Scott, they have that base layer down already, and that should be at least 2 inches thick, and then they'll start with that top layer. So can you kind of tell us, some tips and tricks when putting that top layer on?
Yeah, don't use a paving machine. You cannot use a big paving machine when you're doing that. Also, you can't bend the factory splices, which is the part at the beginning. Like the mats are green, that wire that's green, and there's also the loose cable, that wire that's green, kind of like the same color as this background. But that color is the part that heats. The part that doesn't heat is the black. The black cable. The black cable is 20 feet long. And that black cable is only designed to get from the start of the mat into a junction box. That's all it's designed to. So all of your connections have to be done in the junction box. We're going to show you one of those in a minute. But it's very, very important that you don't use a paving machine and you don't damage those splices. But we'll talk about where those splices are when we get a little bit better picture.
Yes. So this is a really good, I like this picture a lot because it's really showing a lot of different things. It's showing the the mat being installed over on the left. It's showing how you would actually put out the mats as you go, as well as how they have them kind of staged over on the right. So can you kind of tell us, how this worked?
Yeah, we staged all these mats ahead of time before the asphalt guys even showed up, because the asphalt people are going to be there. Let's go, let's go, let's go. And the longer that asphalt sits in a truck, if it's not a heated truck, the longer it sits there, the more difficult it is to work with the asphalt, or they may just go, hey, it's getting too cold, I got to go. So they're not going to wait for you to string cable manually back and forth and tie it down to anything. So you have to have it laid out, ready to go. So what these guys did is that guy on the left with the rake, he's got that area pretty much covered. He goes, guys, bring the mat. And this is a cut and turn mat here. This is one mat that's been cut and turned. So these guys roll it up. They carry it, lay it down. The asphalt guy comes and dumps asphalt on it. Then you can see in the lower right-hand corner, there's two more over there ready to go in that lower right corner. And that's going to be the next one. Once they get this area covered, they're going to take that mat over there and they're going to pull it across and lay it down, and they're going to put the asphalt down. So that should all be there, ready to be installed. And your electrician is going to need to be here, because if you look at the bottom picture there, you can see that gray box. That's your junction box. And that mat that guy in the black has, that mat's got a 20-foot lead that they're going to run up into that box for the electrician, and then they're going to cover it with asphalt. So you need to get that non-heating lead that's 20 feet long along the edge of that wall into that junction box, and then you can start covering it. So the electrician needs to be there for that too, and he's going to be testing it as he goes too.
Yes. So looking at this top asphalt layer, this is a really great video, 10 seconds, just kind of showing how that gets done.
Yeah, notice there are no wheelbarrows here. That's the first thing people push back is, I don't want to use wheelbarrows. Well, you're not going to. You're also not going, if you can show that one more time,
Oh, yeah.
you're not driving this dump over any wire either. So that's why all the wires aren't laid out on the asphalt. You only work your way away from the house towards the road, because that lets you drive the dump truck and dump, go get another load and dump. And that way you're not using wheelbarrows, going up a hill or down a hill, but you're working from one spot close to the house and working out to the road, because you don't want to work the other way, because then what do, right? So that's what we're doing here. And before you start this video, in the lower right-hand corner, you can see where our mats are staged. The next row is staged, ready to go for us to dump asphalt on it.
Oh, didn't mean to play it again. Hang on. There we go. So the junction box, like you had talked about a little bit earlier, Scott, it looks a lot like a bowl of spaghetti. Can you kind of tell us, what we're looking at here? Obviously, an electrician will probably know.
Yeah, the electrician has already put that in there, and they've put conduit from the house into that box, because all the connections from these mats are going into that junction box. And we had a question. I think that might be a perfect time to ask. What is the capacity of the junction boxes? William asked that. A small junction box can hold 1 to 2 of the leads. A larger box can hold between 3 and 8. And then for jobs that have a big wall-mounted a metal junction box on the wall outside, that can hold up to 8 connections in there. So you have 8 connections coming up from the ground, from the heated area, and you're having 8 wires coming from the house to connect to them. That's the thing. So you're really having 16 wires, but 8 leads, right? So you have, or let's use 5, because I've only got 5 fingers on this hand. So you got 5 here. You're going to be running 5 wires from the house to tie them all together. So that's what fits in that junction box. So hopefully that answered the question for you, William. Thank you for supplying that question in advance.
Yes, thank you. So now looking at our snow melting control options, there's a lot of ways to really customize the system to be exactly how you want it. You can have it fully automated. You can have it so that you're turning it on and off yourself. Scott, can you kind of tell us generally what do you recommend? Is it better to automate the system? Is it better to use a timer?
If you're at home all the time, you can use a timer. But a lot of people aren't home all the time. So most of our sales are automatic because you never really have to do anything. When it starts to snow and it's below 38 degrees, that little sensor there on the right side will sense that it's getting wet and that it's under 38 degrees. It'll turn the system on. The thing is, I read some reviews on different products out there, and people say, yeah, my snow melt cable didn't melt all my snow, it left slush behind. Well, your system is working. It's just not working long enough, if that's the case. And that's what hold on time is. That's why I wanted to bring this up now. If your system isn't melting snow, it could be that your hold time isn't set long enough, because that sensor is only going to tell the control it's a snow event right now. Hello, it's a snow event, turn on. And it will keep yelling at it the whole time. Keep this on until either the snow stops or the temperature goes above 38 degrees. At that point, it quits going, snow is on. Then it stops. Then the control goes, all right, the snow event is over. So now what I'm going to do is there's a little knob in that lower right-hand corner that you can set from 0 to 8 hours or 8 to 10 or 12, whatever the individual control has. Different ones have different times, but that's the amount of time it runs after the event has stopped. So if someone says, yeah, my system melts, but it never melts all the snow enough, we know it works, right? Because it's melting the snow. It's just the hold on time needs to be turned a little bit higher or maybe a lot higher. And when people get this first snow system, we don't know what to tell them. We always say start in the middle, because every place is different. Every system is different. Every installation is different. So we always say start in the middle, because somebody puts 0 and somebody puts 10, always put it in the middle and start there. If your snow always melts and it melts hours ago, then turn it a little bit less time. If it's not melting all the way, turn it a little bit more. And you may have to adjust it as you go. The good thing about this control is if it's set to maximum and you just got 36 inches of snow and it hasn't melted at all yet, there's a little button there at the bottom that just says start. You can manually start it and run it. And when it melts, you manually stop it. So this is an automatic control that you can, if it does its thing and still needs more, you can manually turn it on. And then when it's done, you can manually turn it off. And then it's always looking for the next snow. So by manually turning it on or off, you're not ruining anything. It's still going to be looking for snow. So that's what's so good about this control, is it'll do it automatically and it'll run it for the amount of time it needs. And if it doesn't quite get it all, you can still have a manual ability to get in there and go, hey, I want to turn this on for a little bit.
And I know you had talked about it briefly, the over temperature sensor in terms of where it goes. But can you kind of talk to or speak to how that works with a automated control, or how, how that plays into it?
Yeah, the state of Rhode Island and the state of New York, they say that you have to have a control that senses the temperature in the slab, because they want it to turn off when it gets to a certain temperature. So this is the control you need to comply with those electric requirements of the state. The state says you have to have something sensing the temperature in that slab, because that keeps it from coming on in the summer. Because if you set this over temperature to 70, anytime it's over 70, it'll never turn on. And if your slab is 70 degrees in the middle of the winter, your snow is melting. You don't need to turn it on for anymore. You just let it go. And then when it gets below 70, it'll turn back on again. So you want to watch out for that. So that's what that's for, is that manual stop here point. No need to turn on this summer, and there's no need to turn it on if it's 70 degrees.
Definitely. So looking at this, I think this is a really handy drawing showing exactly how everything kind of fits together and where all of the different components are going to go. Specifically, which components can be outdoors and which components can be inside. And can you kind of tell us, what the difference is?
I'm the king
Not
of
the
common
difference
sense.
between inside and outside, obviously.
I'm the king of common sense because I have none. I just watch people with common sense in awe and amazement. But even I know that you want to put the heater mats outdoors. You don't want them inside. They're not going to do any good inside. You want the J boxes out where the heating mats are because that's where your connections are. Now, sometimes if you're heating up to your garage and the controls right inside the garage door, sometimes you don't need a junction box, but jobs that don't need junction boxes are few and far between. But what that J box is, you have to have one 9 times out of 10 because you can't make any splices in the asphalt. You can't extend the leads because that's not to code. The National Electric Code doesn't let you extend the leads. Your main job from that cable is to get it to the junction box. Then the electrician can put 500 feet of cable back to wherever it needs to go as long as he does his voltage drop calculations and gets that straightened out. But the heating mat has a 20-foot lead, and that 20-foot lead is only to get into the junction box. So both those things have to be outside. Now, if you want a high temperature sensor in the slab, well, obviously the slab is going to have the heater cables, and the heater cables have to be outside, right? So that's where your high temperature limit sensor is. And your aerial mounted sensor has to get rained on, or it has to get snowed on, and it has to see what the outdoor temperature is. It has to feel it. So it has to be outdoors too. I can tell you that there have been people that have mounted the aerial sensor in the ground and covered it, which rendered their system useless because it didn't work. But one very major important thing is when you're getting this stuff that's outdoors inside, it has to go through conduits, right? So there's a conduit that goes from the heater cable to the J box sometimes, but there's definitely a conduit that goes from the J box to the relay panel. You have to. These cables have to be embedded, and the non-heating leads have to be in conduit. Those cables have to be protected by conduit. So when that wire comes out of the heated area, it has to be in conduit all the way to the next spot. You can't bury it. Like direct burial wire is a type of Romex that you can just bury in the dirt. This product isn't direct burial. It has to be protected by the National Electric Code and by design inside a tube, which is a conduit. You have to pick the right conduit to comply with your local code, be it PVC or 3/4 inch rigid metal conduit. National Electric Code says 3/4 inch rigid metal conduit, but the local code goes, yeah, just use PVC, that's fine. You have to go by what your local code says. So that's where the conduit comes in play. The reason why I brought that up is because that high temperature limit sensor is low voltage. See where it says on that line that goes from the controller to the temperature sensor, low voltage and low voltage? Those wires cannot go in the same conduit as the wires that the heaters go in. They have to be separate. And if you put either one of those sensors in the same conduit as the high voltage leads, it'll make the sensor not work. So your system will never turn on or off, and it's against code. So you can't have a low voltage and a high voltage wire in the same tube. And if you do put them in the same tube, your system will not work. And half a dozen times over the last 15 years, at least a half a dozen times, we had a system that didn't work because they put the high voltage cable and the low voltage cable in the same conduit. So it won't work. So that's the first thing is to check that out. So that's all the outdoor stuff. I don't want to go on too long, but that's why outdoor stuff is outdoors. Notice that the relay panel is indoor only. The relay panel is a NEMA 1 box, which means it's got cutouts, it's got knockouts in it, which means any rain that falls on it has a good chance of getting inside. That's why it has to be inside. These relay panels are mounted indoor, and it says right on the inside of the lid, NEMA 1, indoor use only. And the controller is mounted indoors, and so is the remote control. You don't want somebody walking out, hey, could you go turn on the system? Yeah, let me get my boots on, let me go get my coat on, and I'm going to walk outside so I can manually turn my system on. I mean, that's not very customer centric, is it? We'd want that to be either in the basement, and then you can put the remote control override in your living room or in your kitchen, and that'll remotely control your control that's in the basement. So those are the things that have to be all on the inside. If you put your relay panel outdoors, it will eventually fail because it's being put outdoors. It'll rust, water will get in the connections, and it will go bad. So please don't do that.
Definitely. Yeah, we do see that occasionally. So it's always good to remind people.
And if you look at that aerial mount, if you go back to the aerial mount sensor, notice how the aerial mounted sensor isn't right up against the wall. Notice how it's put out over here, because you don't want the sensor sitting right next to the wall, because snow very rarely hits right next to the house. So the sensor has to be out somewhere that's going to get hit by snow. Very, very important. And I'm glad I made you go through that again, because the sensor has to be somewhere where the snow can hit it. And that's not under the eave. It's not right next to the house. I've gone out and looked at numerous systems that didn't turn on, and the sensor is mounted right next to the house. And if you go out there, you'll see that there's a 1 foot area next to the house that gets no snow, right? So if you've ever walked outside and you see on one side of your house, there's a foot where the snow never goes. And then on the other side, sometimes there is. I found a lot of sensors in that spot where there's no snow. And that's why.
Yeah, it definitely takes a little bit of thinking to figure out exactly where your sensor is or should go. And I usually recommend putting it on the same side of the house as where the actual heating is, instead of putting it, on the north side and your driveway's facing east. Something like that can kind of also affect how much snow it's going to be picking up.
People love to put them in bushes, like, oh, I'm just going to stick this about an inch above the bush. Well, that's fine for the first year. Then the second year, then the third year, and the fourth year, now the bush is completely covering the sensor. So please don't try to hide it. Put it somewhere where the snow can find it.
Yeah, be proud of your aerial
Yeah.
sensor. So this is the finished project. And as you can see, it is a really beautiful one. And we're actually going to go over the full installation video here. And Scott, do we want to talk about the video library
Yeah, I
that we
mean,
have available?
yeah, we're right there on that page, and show them how the filters work, because that's the answer to the mystery.
Yes, definitely. So before we show you the video, I do just want to point out, if you go to our website, if you go to resources, you'll see that we have this video library with all kinds of information. And then you can actually filter by the specific products you're looking at and what you're looking for. If you're looking for videos on installation, you can see all of them here. If you're looking for videos on the product itself, we'll kind of walk you through that. So lots of different options, lots of ways to learn about the system. And then this
Before you leave this page, can you just scroll down a little bit? Because we had a question from Jeff, and we also had a question from Gerald, both about what are to-dos when trying to cover heat a somewhat steeper inclined existing asphalt driveway, basically a retrofit into a large rectangle area. When you're doing asphalt, we know that you don't want to use loose cable unless you have to. And then retrofit into existing concrete drives, asked Gerald. Well, both of these, Jeff and Gerald, if you look at the videos, and on this row here is right where you're pointing, where that hand is, if you can move it, there we go. That's how to retrofit an existing driveway with the snow melting system. That's an asphalt drive where they poured concrete inserts. And then if you go there, where you're pointing there's where we've actually taken cables and cut into the asphalt and laid the cable down in there. So there's two different ways that you can do it. You can cut strips, and this video shows you exactly how to do it. You can cut strips and then push the cable down into it. It's very time consuming, takes a lot of time. Your cuts have to be pretty good. And then on the one on the right shows you how you can use the mats just to lay them in and then cover them. So those two videos should answer your questions for Gerald and Jeff. So thank you for asking those.
Yes, thank you. And then this is actually just a video of the project we showed you. Can you hear this, Scott?
No.
Do I need to officially tell it that I want it to say share computer sound? That should do it.
There we go. There's the binder coat. There's the drain we worked around. There's the sensor in the upper left-hand corner. There's a sensor again with the conduit. Pushing the leads into the conduit. You're not going to see a wheelbarrow anywhere in this video.
So if you're scared of wheelbarrows, you can watch this video.
Oh no, it's going to be too much labor. Yeah. Notice how there are no mats where the dump is. Right, they're driving back and forth in a binder coat. Can you hit pause right there? I'm sorry. I think we kind of, if you go back just a split second there in the video, there. Notice how they're using the back side of the rake. They're not using the sharp edges, because if you take that rake and go like this and hit the cable, you're going to cut into it. Also, when you're using a shovel, make sure that you put a piece of duct tape on the shovel to soften it up so you can move that around. But I wanted you to see this, and great stop here, because that's where they're using rakes upside down. You don't want to hit that cable with the tines of that rake.
Yes, definitely. I always say, like, it doesn't need to be treated with kid gloves. It's a hardy material, but you do want to, be nice to it.
Yeah.
Don't do anything that will actually like just harm the system that will do something bad.
I notice how we're working away from the house out to the street. Share this, and here we are, we're moving the other parts in, but please share this video with your asphalt person, because as soon as they see this, they're gonna go, oh, why didn't I think of that? I mean, we fight this battle all the time. And as soon as they see this, we go, okay, I see what you're trying to tell me. But until they see the video, they're pretty skeptical sometimes. And there's your roller. Your roller can be put on it after it's covered. And there are your connections. All those leads can be cut to whatever the national or the local code says. Local code will tell you how long those extra pieces have to be, and then you just cut it off. That part can be trimmed. You can shorten the non-heating leads, but you cannot cut the green heating cable.
Yes, and we'll probably say that 50 times today. We won't say it too much, though. Do not cut the cable, please. All right, so this is the project cost breakdown. So for that full coverage driveway, you are looking at, with the mats, the controls, the sensor, and all the extras that you need, you're going to be looking at right about $8,149. And now looking at tire track coverage, it's going to be, again, similar materials, similar breakers. However, you can see there's a lot less square footage covered, and the operating cost is quite a bit lower because of this. So actually looking at the SmartPlan, you can see how there are, 2 tire tracks, right, Scott?
Mm-hmm. With 4 rolls. On this plan, notice how the rolls start. The triangle is the beginning of the roll and the square is the end. So notice how all those triangles are in one spot, because that's where we want to get all the conduits to come there. Your local code may say that only 1 conduit per lead, or your local code may say you can put 4 leads in that conduit, as long as the conduit is sized appropriately. So that's what you're going to want to check with your local code, what the conduit rules are, and what kind of conduit you can use, if it has to be rigid or not. but that's where your start points are. You don't want to start one way over there and start one way over there, and then you have 2 or 3 junction boxes. Then your electrician is going to go, no, let's just put them all right here. So that's why it's set up this way.
All right, and then this is that same project in action. So you want to make sure that you are spacing those mats according to that SmartPlan, and then the final layer of asphalt will go over those. Now, when the system actually turns on, keep in mind that only the areas with the mats will melt. The heat, as you had said earlier, really will radiate about 1.5 inches or so laterally, but it's not going to heat the entire driveway if you're just doing a couple tire tracks.
Yeah, and I want to go back to the question that Jeff had. They have an existing asphalt driveway. What you can do is you probably want to just do an area, sometimes down by a road, you might do it a rectangle, then tire tracks getting to it because you want to be able to stop before you get to the road. So what a lot of people will do is they'll put a, I don't know, 12 by 12 or 20 by 12 area there. Or just double up a couple runs of which we're going to see in the video here. But Jeff, what you can do is if you have an existing asphalt, you could literally just put these rolls on top of that asphalt and do another cover over the top of it. A lot of people do that as long as your asphalt's in good condition. Now, if your asphalt's falling apart and you put cable on it and put asphalt above it, it's still going to fall apart and it's going to ruin the cable. But if you have a nice solid asphalt drive and you go, we're almost sliding into this road every single time, is you lay down your product, you grade up to it, and then do a 2-inch cover over the top. And that way you're not retrofitting your entire driveway. You're just addressing that area at the bottom. So that might be a thought, because I have seen a couple of those recently.
Yeah, cool. Good information to have. And you kind of mentioned this, Scott, how you can actually just take the end of the mat and turn it around, give yourself a little bit more space. And this is the finished project at work. A snowstorm came through and you can see you can still easily get in and out of that driveway. So looking at the installation video for this one.
Welcome to our snow melting under asphalt video. Now, as you can see, a few of the leaves are falling here. It's, as they say on TV, winter is coming, so we need to get this thing ready to go. So what we're going to do is we're going to be installing tire tracks in this area in front of me and the area behind me. Right here we have our electrical connection spot. We're going to be putting a junction box in there, and then it's going to make it easier for the homeowner to make an exit out of this, make a little roundabout area here that's going to be prepared with snow melting under an asphalt surface. Remember, whenever you're planning some of this excavation, you always have to call and make sure that you locate your electrical, your gas, your sewage, that sort of stuff. You can see here that the gas and the electricity have both been marked, so we know to avoid these areas. All right, what we've done now is we've excavated the dirt and we've taken a steamroller and rolled it down. What's next is about 6 inches of compacted gravel. They're going to dump it in here, then spread it out. Then they're going to compact it down. Because after that 6-inch layer, we're then going to put a 2-inch binder coat, put the heating cables over that binder coat, and then put a 2-inch top coat on top of that. Now we have the second layer of gravel in. The gravel's been compacted, and now we're just beautifying the edges at this point, getting the excess dirt out of the way so when the paver comes in, the machine doesn't get held up by anything along the edges. What's also going to happen at this point is instead of this rough edge around this perimeter here, they're going to take a saw and saw cut a nice straight edge into this.
And there's your asphalt machine for your first layer.
Okay, we have the binder coat down, and what we're going to do now is we're going to take the rolls and roll them out. What's going to happen here is we're going to stake them in place, and that's going to keep them tight. Then the guys are going to shovel asphalt over the top of these. You never ever run a paving machine over the top of the cables. So we're going to lay them out, and as they're pouring the concrete on top with shovels, I'm going to be pulling them to keep them tight. until we get down to the spot where our next group of wires are going to be. Right now, what we've done is we've measured out the distance because this is tire track coverage. So you need to make sure that they are the correct width, and that's what we've already measured and got them set out for. So we're going to go ahead and get started.
We just mocked this up so you can see what full coverage looks like, but this would take a lot of power. Here comes the dump. They put that over the top. And this is a fine-tuned machine. Now they've got the asphalt down. They start finishing it as the other people start moving it across. So it's all one big orchestrated from up to the house, out to the road. And there's our sensor, our over temperature sensor, which has to be.
Okay, here we can see where all the electric is going to the asphalt. So you can see we have 4 mats right now. We have 4 pieces of conduit going in for each mat. And we also have a conduit going in here for the low voltage temperature sensor.
Notice how we haven't rolled all the rolls all the way out. We just get enough to dump. Then when they're done, they move it out a little bit further and dump again. And that's what we're doing here. Have we said to never cut the heating cable? Did we mention that earlier?
I think we did, but we should probably reiterate it. Don't cut the heating cable.
Okay, the job has been paved over and the guys have left, and what's left behind is this junction box. So this spot right here is where the mats are being attached to the power supply coming from the house. Now this box a lot of times can be hidden. It can be put in the ground. If you have an in-ground box, you can use those. Some people like to put them in a decorative wall. But the one thing is you have to be able to get at them. If something ever goes wrong, you need to be able to get inside the junction box to disconnect, reconnect, to do your testing. So the box can never be completely sealed off. You always have to have good access to it. So now we're inside the house, and this is where the electrical part comes in. We've installed the new controller up here on the wall, and we've got it connected to the wires running out to the driveway. Now what we're doing is we're working on the supply power that's going to supply the voltage to those wires. We've also had to supply a supply circuit, which is the power that the unit up here operates on. So what you're doing is you're sending power to this box to make it control, to keep it lit up, to keep it working all the time. And then we're sending power from the circuit breakers over here to be switched by the relays in this controller on out to the heating coils and make them melt the snow. All right, here we are. We have a completed driveway, and there's no way that you can tell that there is any electric heating underneath this surface except for one thing, and that's the junction box right here. So if you'd like to learn anything else about heating your driveway with electric heating products, just check us out at
All right, so WarmlyYours.com, absolutely. And then we also do have a very quick video of the system in action during a very snowy day after it was installed, and you can see it's really keeps that area completely clear of snow.
This is all done automatically too. No one's turning switches on or off. This is simply does it all by itself.
And there you go. A working snow melting system.
Yep, I love to see it melt.
Yeah, it's very satisfying. So the project cost breakdown for this, obviously with less coverage, you're going to be saving quite a bit of money. So you're looking at 5,482 again for those mats, all the controls, the relay panel, snow melting plaque, everything that you need.
You know, it's really cool because the driveway's longer than that driveway is, and we covered it with less money.
Yes, absolutely. So just some last minute tips for asphalting with snow melting. Again, make sure that you have a megameter to properly test those heating elements. You want to make sure that you're using duct tape on the edge of shovels, that you're using rakes upside down, minimize any kind of sharp edges that could potentially ever come in contact with that heating cable. And you also want to make sure that you're not walking on or bending the factory splices for the heating element itself. So I think that's it. Did we get to all of the initial customer questions, Scott?
Yes.
All right. So do we have any now? I think we're good. Let me see here. Oh, we have one question and answer. Maybe if it will open. Are you able to see that customer question, Scott, under the Q&A?
Let me check. Yes, why are relay boxes only offered for up to 8 relay switches? What if you're doing a driveway of a couple thousand square feet? Well, first of all, we'd probably try to get you down into tire track coverage as opposed to, I guess I can hit answer live. We would try to get you into tire track coverage to save you money and upfront money, operational cost money, that sort of thing. The number of relays is based on the number of rolls that you have attached. So each relay inside, there's a 12 pole relay, which means it's actually 6 cables because a 240 cable is 2 poles. So 2, 4, 6, 8, 12. If it's 120, then you only use 1 pole, a hot. The neutral's connected over here. So another hot, another hot. So you can actually do 12 120 volt mats in a 12 pole relay, and you can do 6 240. 240 needs 2 poles, 120 needs 1. So the number of wires that you have installed will determine the number of relays that you require and the number of boxes it takes. So that's how that's figured out. Very good
Awesome.
question.
And then yes. And then we have a question from Marwan asking about installation in concrete slabs. Just kind of, I think, looking for, some differences, how that works with concrete versus installing an asphalt.
Concrete doesn't require an over temperature sensor, so you can use a less expensive control. There's also a video. If you could, Lynn, could you go back to is it possible for you to go to our video page? And there's a page that we shot that will answer all of his questions exactly. And that is, if you can go down or go to snow melt and installation. And then if we take a look, this is going to be by visual only, all the way there at the bottom in the middle. So that bottom row, the one in the middle, there, snow melting and de-icing cable systems in concrete. This is the same if you're doing a patio, or it's the same if you're doing a driveway. So it gives you the layers that you need to do. We have cross sections, like we showed you the cross section of asphalt, cable, asphalt. It's going to show you the different layers when it comes to concrete. It's a different installation. Concrete, what you do is this video would show it, but you set up the rebar and then you put the mesh down. And the one thing you have to do is you have to make sure that the clumps of stone in that concrete are smaller than 3/4 of an inch large. So you'll just say sub 3/4 inch aggregate. That'll flow through the mesh that's that the cable holds onto. It allows that to flow through, and then you put the cable and the rebar halfway in the pour. So if you have a pour like this, it's going to be propped up, and you're going to pour concrete through it, and the concrete will go right there and put it right in the middle. So that video will show you exactly how to do it. We can also send you a cross section that shows that. So if you want to, if you do a link, if you go up to home there in the upper left-hand corner, go there, and in the search button up to the right in the center, put cross section. I use this all the time, so I want everybody to see where it is. And if you look for snow melting and slab heating application cross section comes up there. If you just click on it, you can see all the different cross sections of how it's put in. So hopefully that video link and this cross section, we can get this to you if you'd like. We'll show you how that goes in, but watch the video and this will all become self-explanatory.
Yes, definitely.
Thank you.
All right. And I think that that's all I am seeing for now. So our next webinar will be in July. Again, it's right here on Zoom, and we'll be talking about how we are introducing our new Pro exclusive electric floor heating ruler cable. So be sure to join us for that. We also offer daily training sessions right here on Zoom, usually hosted by me or Scott, shorter, 5-10 minutes usually. So feel free to pop on in, learn a little bit, or ask any questions that you might have. And for the month of June, we are offering 10% off of select Temstone floor heating products. We also are offering 20% off of that new Pro exclusive ruler cable. So definitely reach out to learn more about those promos and more about the products themselves. And then once this is done, we'll send out an email shortly asking about your experience during the webinar today. We'd love to hear any comments, suggestions. If you have thoughts for future webinar topics you'd be interested in seeing, definitely share that with us. We would love to hear from you. And of course, you can always reach out, give us a call, shoot us an email, visit our website, which you can see has a lot of information on it. Definitely don't hesitate to contact us if we can be of any assistance. And I think that that is all that we have today. So thank you so much for joining us, everyone. Until next time, as always, stay warm.
And be radiant. Thanks, everybody.